Just going to talk about something called reference angles. So for theta of any size, like we did in the last lesson, the reference angle, theta dash, the reference angle, is the acute angle. All right, so it's very important. Theta is between 0 and 90 degrees. It is an acute angle. Or if you're thinking radians, it is theta dash 0, theta dash is less than pi over 2 if you're thinking in radians. It's the acute angle that the terminal side makes with the x-axis. What does that mean? Let's just do an example, okay? Sketch the angle theta, and then determine and show the reference angle theta dash. I say theta dash, some people say theta prime. Again, like I'm doing, we don't need a ruler. 140 degrees, which quadrant is that in? So remember our quadrants, you've got quadrant 1, quadrant 2, quadrant 3, quadrant 4. Counterclockwise from the positive x-axis. 140 degrees, so this is 90, this is 180, 140 is going to be somewhere in the middle. Okay, and there you go. There is our angle theta. Done. Now what is this reference angle thing? So the reference angle is the acute angle that the terminal side makes with the x-axis. So just to clarify here, this is called the initial side of the angle, and the terminal side is where the angle finishes. So this is the terminal side. So we've got our initial side and our terminal side. The acute angle that the terminal side makes with the x-axis. So here's our terminal side here. What angle does this make with the x-axis? Well, it makes this angle here with the x-axis, but the reference angle's got to be acute, less than 90, so we're going to do it this side. So here is the reference angle here. There it is, okay? So it's always got to be with the horizontal. That's another way you can think about it. With the x-axis, or in other words, with the horizontal. Let's figure out what it is. Well, if this is theta is 140 degrees, what's this going to be here? How short of 180 is 140? Our acute reference angle is going to be 40. Does that make sense? 140 plus 40 is going to give 180 total. Okay, so there it is. Let's try another one. If you're confident, just pause me and work ahead. Try and get the answer before I do. Same thing. This time theta is 235. So which quadrant is that going to be in? 0, 90, 180, 270. 235 is between 180 and 270. So it's going to be down here somewhere. So let's draw theta first. There's theta. Theta is 235 in the third quadrant. Now what is the acute reference angle here? Is it here? That's an acute angle. What do you think? It has to be made with the horizontal, so no, it's not here. Where is the acute angle that this terminal side can make with the x-axis? It is going to be in the third quadrant down here. So there it is. There is theta dash. What is theta dash this time? Well, we've got 180 plus something equals 235. How are we going to figure out what that theta dash is this time? We're going to do 235 minus 180 to get this difference. 5 minus 0 is 5. 3 minus 8 can't do. 13 minus 8 is 5. 55. So theta dash is 55 degrees here. So that is 55. We've got 180 plus 55 gives us our 235. Those are examples in degrees. Let's have a look at C and D where we're going to think in radians. Here we go, 2 more. Theta is 5 pi over 3. Here we go. Doing our angle here in standard position, 5 pi and 3. So what we're doing here is, if we've got pi over 3, this is going to be 5 lots of pi over 3. And pi over 3 is 60 degrees. We're going to divide this up into blocks of 60 degrees. So this is 60, 60, 60 to make 180. Or pi over 3, pi over 3, pi over 3 to make 3 pi over 3. And remember radians? 3 pi over 3 is just pi radians, which is 180 degrees. Pi radians is 180 degrees. So where is 5 pi over 3? So here we go. Here is our initial side. Pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. Here it is down here. 5 pi over 3 is down in the fourth quadrant. Now what about the acute reference angle theta dash? So here's the terminal side, and it has to make an acute angle with the horizontal. So it's going to be here this time. Here is our acute reference angle, theta dash. And how are we going to figure out what that is? Well, it's going to be 360 minus theta. 360, 2 pi, minus whatever theta is, 5 pi over 3. Common denominator, what's that? This could be 6 pi over 3 minus 5 pi over 3. Just pi over 3. Here's our acute reference angle for this case here is pi over 3. So you could just see that 60 degrees, isn't it? So our acute reference angle is pi over 3, 60 degrees. Last example. 15 pi on 4, and it is negative. So what we're going to do now is this is going to be negative 15 lots of pi over 4. And what's pi over 4? Pi is 180. What's pi over 4? Dividing that by 4 on both sides, it's 45 degree lots. So I'm going to divide each quadrant in half, so I get 45 degree angles here. So we've got 45, 90, 135, 180. Pi on 4, 2 pi on 4, 3 pi on 4, 4 pi on 4. 4 pi on 4 is the same as pi, which is 180, okay? Let's do it. Here is the initial side starting at 0, positive x-axis, so we're going to go back 15 lots of 45 degrees. 15 lots of pi over 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We're back in the first quadrant. There is theta is negative 15 pi on 4. What is our acute reference angle? Where is it? So it's always got to be to the horizontal, and it has to be acute. So it's going to be up here this time. Remember, it's not here. That is not to the horizontal. It has to be with the horizontal. And how big is that? Well, that's just 90 degrees cut in half, isn't it? All right, the acute reference angle here is just 45 degrees, or pi on 4, and that is it.